In this lesson, we're going to look at complex and imaginary numbers. They're pretty much the same thing, but a complex number is when we take the square root of a negative number. You've been told so many times you cannot take the square root of a negative number. Well, you actually can. It's just not a real number. It's what we call an imaginary number. So today we're going to be looking at solving some equations and seeing if our answers are imaginary or real. So if you look at this first box here, it says I have no real solution. So if you look at x squared plus 1 equals 0, to solve this, I'm going to subtract this 1 over. And subtract the 1 on both sides. And then I get x squared equals negative 1. And to solve for x, I have to take the square root of both sides. So I'm going to get x equals, the square root of negative 1 is what we call an imaginary number. It is I. Okay, so when the square root of negative 1 is always the letter or the symbol I. Okay, these imaginary numbers then can be written in complex form. Okay, complex form has two parts to it. Okay, complex form looks like a plus bi. Okay, the a part is an actual real number like 5 or 7 or 2. And then the bi part is your imaginary part. Now, we have powers of I, and we're going to use them later. But I to the first is just I. And these powers right here you're going to need to have memorized. I squared is negative 1. When we start multiplying these things, we're going to get powers of I, and we're going to have to convert them over. So I squared is negative 1. I to the third is negative I. And I to the fourth is positive 1. And this pattern repeats. I to the fifth is I to the sixth is negative 1, I to the seventh is negative I, and I to the eighth is 1. So guess what I to the ninth would be? We're going to start that pattern over. I to the 10th, negative 1, I to the 11th, negative I, and I to the 12th would be 1. The pattern keeps repeating through every 4 numbers. So determining the power of I. What if I give you something like, what is I to the 56th power? Well, I don't want to have to keep writing this pattern over and over and over till I get I to the 56th. So the way to do it is we're going to take and we're going to divide our exponent by 4. And the reason is there's 4 exponents in each of these patterns. It repeats after the fourth one. So I want to say 4 goes into 56. It goes once. That's 4. 16. It goes 4 times. That's 16. Oh, I don't have a remainder. So if I don't have a remainder, that means that I am here at I to the fourth. So this thing equals 1. Okay, let's do another one really quick. What about I to the, let's say 43rd. Okay, so we're going to take and we're going to divide our exponent by 4. Okay, it goes into 4 once. That's 3. It goes into 3 0 times. So my remainder is 3. This 10 on top, that has nothing to do with it. I look at my remainder. Okay, my remainder is 3. Since my remainder was 3, I'm going to come back up here to my pattern to I to the third. And I to the third was negative I. So that equals negative I. Okay, solving equations with complex solutions. Okay, to solve an equation, we're going to do the reverse of my order of operations, just the way you would solve any equation. Then once we get down to the answer, we're going to have to take the square root And if there's an imaginary part, we're going to have to take that imaginary part out. And it comes out as an I. So if I have something like the square root of -4, well, I'm going to divide that into a real and an imaginary part. The square root of 4 and the square root of -1. Well, the square root of 4 is just 2. And we already talked about up there, the square root of -1 is I. So I'm going to put them together and my answer would be 2I. I know that was quick, so let's go over some problems together. The square root of -9, okay? So I'm going to divide this up. Square root of 9 and square root of -1. Now, you don't always have to divide it up. You know that the negative should come out as a I. So the square root of 9 is 3. Square root of -1 is I. So that just gives me 3I. Okay? Square root of -32. So I'm going to have the square root of 32 and the square root of -1. 32 is not a perfect square, but I can break it down. 16 times 2 is 32. Okay. The square root of 16 is 4. And then I have that square root of 2 that has to stay under. And then the square root of -1 is I. Now that I comes out in front. It goes with the number part. It does not stay under the radical. It comes out of the radical. So that would be our correct answer. Okay, example 2. Solve the equations, then simplify. Okay, I'm going to solve it just like I would a basic equation. Subtract the 13 over. X squared equals -12. To get rid of the x squared, I'm going to have to take the square root of both sides. X equals the square root of -12. Now I'm going to have to break that down. Okay, so that's going to give me the square root of 12 and the square root of -1. 12 can be broken down. 4 is the perfect square that divides into it. Again, if you don't know how to break down these non-perfect squares, let me know and I will send you a video of how to break them down. Okay, so I'm going to take that perfect square of 4. That is 2. Square root of 3 stays. The square root of -1 becomes I, and that goes out in front of my radical. Okay, solving the next one, I'm going to add the 1 over. I get -2/3 x squared equals 18. I'm going to multiply by -3 over 2, the reciprocal, because then that goes away. And I'm going to do some little magic here. 2, that goes 9. So that is -27. Take the square root of both sides. So now I'm going to have the square root of 27 and the square root of -1. Square root of 9 goes into 27. Square root of 9 is 3. And then I have square roots of 3. The square root of -1 is an I. So that comes out front. Okay. Oh, and I did forget, whenever we take the square root, I totally forgot, we have the plus and the minus on both of these. Whenever we take the square root, because like the square root of 9, 3 times 3 is 9. Also, -3 times -3 is 9. So we got to be careful with our plus and our minus. Example 3. If I'm multiplying these 4i times 7i, I'm just going to multiply parts. 4 times 7 gives me 28. I times I is just like x times x. It's going to be I squared. And then, this is why we need to know, I'm going to go back over here. My I squared was -1. So I'm going to turn that into 28 times -1, which is going to give me -28. That's why that pattern's so so important. Okay, I square roots of 3 squared times -8i squared. Okay, this squared, we talked about it, it's going to go to both things. So I'm going to get I squared square roots of 3 squared times -8 squared times I squared. Okay, square root of 3 squared, actually what's nice is the squared and the square root cancel. And that gives me 3i squared on this side. Negative 8 squared, negative 8 times negative 8 is 64 I squared. And then I'll multiply 3 times 64. That's 192. And then I squared times I squared. I'm going to add those exponents and get I to the 4th. Now, I can't leave my answer in terms bigger than I. So I'm going to come back over here. I to the 4th was, in our pattern, 1. So that's going to give me 192 times 1, which is just 192. Okay, so you need to finish up this daily practice, upload it to Google Classroom, and then I will assign some IXLs also for you.